Whoops. I know there's a ring light. My dad uses it for church stuff, so I'm taking advantage of it. Don't judge me. Now, I know what you're saying. Camilla, we already know how to do ray drawings. I know. This is just a review. Just bear with me here, and we're gonna go from here. So, when you put light through lenses, they change the size. They can change the size and the orientation of an object. So we're gonna start with a converging lens, which is one that's shaped like this. So this is our lens, focal points of the lens, and we're gonna have an object, which I will show as an arrow. Converging lenses make real images that are upside down when the image is past the focal length. If it's in between the focal length and the lens, then it will create a virtual image, and that means the image won't actually be real. There are basically like 3 rays you can draw to try to get the object on the other side of the lens. Our first line is going to go parallel with the axis. Our second line is going to go to the center of the lens. And our third line is going to go through the focal length to the lens. So after it hits the converging lens, there will be diffraction, and the direction of light will change, which makes it so that our object can be seen differently, or like when it's seen across the lens. So this first lens that's parallel will go through the focal point of the other side, and that should be long enough. The one that goes through the center will actually go just straight. It'll keep going without the light bending. The third line will start once it goes through the focal length. It will go parallel to the axis. So they didn't intersect perfectly, mostly because these focal points are probably not exactly accurate, and ray tracing is kind of hard. But where the 3 lines intersect, you usually only draw 2 of the lines to see where they intersect, and you use the third one to check. But since, this might not be very accurate, we're gonna say that the resulting object ended up being here. Now, this is obviously inverted, okay? And there's an equation we can use to measure the change between the object and then the one that was shown through the lens. So this is our focal length equals the inverse of the distance between the image and the lens plus the inverse of the distance between the object and the lens. We're going to say this was 5 centimeters. This is the focal length is 10 centimeters. If you plug in 10 centimeters for F and 20 centimeters for DO, which is the distance between the object and the lens, what we get for the distance between the image and the lens is 20 centimeters. And now we can use another equation to figure out how big this ray is. Our magnification equals the negative of the distance between the image and the lens and the object and the lens. The distance between the image and the lens is 20 centimeters, and the distance between the object and the lens is 20 centimeters. Then we know that this arrow, even though it may not seem like that because of the difference here, they're actually the same size, and this is inverted, so this is negative. And that is ray tracing with a converging lens. And now we will do a diverging lens. Diverging lens is shaped like this, so they're divergent. The ends of the lens are away from each other, divergent. Or that's how I remember. So we're gonna say the focal length is 10 centimeters again. I want it at 25 centimeters just because. For your diverging lens, your 3 paths of light you will use are slightly different than the converging lens, but they're also kind of the same. It's just you need to remember the rules. One of your lines is going to go parallel with the axis again. Another one of your lines is going to go through the center of the lens. And the last line will go through the lens to the focal length. Here are your 3 lines. Your first line that's here will actually go this way. Since it's diverging, instead of bringing all the lines together like it did with the converging lines, all the lines that go through this lens will go outwards on the other side. So if you're here, it'll go up, or if you're here, it'll go down. This line will go up this way, but when you trace back, it'll actually hit the focal length here. Your line that went through the focal length and through, you are going to trace back from the center of the lens exactly parallel with the axis. And then your last line that went through the middle of the lens will actually, it'll just keep going through perfectly. Because, yeah. And so this point is actually a lot better than the one I did last time. These 3 lines intersect here, which means that our image is here. The image is not on the other side of the lens, so the image is virtual, and it is upright. And as you can see, it is much smaller than our original object that we had. We're just gonna place this calculator here, and you'll see the whole whiteboard, and you can see how with these lenses, how the size of our object when we look at the image will change. Hi, I'm still here behind the camera this time. My glasses may be a bit dirty. I will put the glasses through, and the image is slightly smaller. See how the image got smaller? Which shows that our object would be this large, and our image through the glasses lens is smaller, which proves that this works. I hope you liked that. My drawings, I hope they were nice and pretty. I used the ruler even though it's a little bit broken. So yeah.